This lecture talks about the historical surveying techniques and retracement aspects relevant to the legal aspects of land surveying. So when we're surveying a boundary of an existing piece of property, we must follow in the footsteps of the original or previous surveyor, regardless of when that survey was conducted. It may have been 1832, it may have been 2022. And especially in the southeastern United States, that can mean a lot of different things. Practicing surveyor must understand the possibilities that surround the previous description that's being retraced. We talk about retracement surveys a lot. So retracing as a word doesn't of its own mean following in the footsteps. Simply it means to survey an existing boundary. In the legal terminology, a retracement survey, according to the Georgia Plat Act, means to resurvey the boundary of an existing piece of property. The word retrace or retracement, retracing, means it's composed of two parts. Re is a prefix originating from Latin that means again, or to indicate repetition, doing something over. Tracing in this realm means to copy or duplicate something. So we are again duplicating the boundary as it legally exists. So we must be very careful not to invent a new boundary, not to invent a new call, not to make assumptions or to give up too easy and put a new monument in the ground where a corner does not actually exist due to failure to properly retrace the steps of the previous surveyor. For example, if you compute this bearing that says southeasterly with the assumption that it's south 45 degrees 00 minutes 00 seconds east, and it says 300 yards more or less, and you don't find anything, so you just set a pin 900.00 feet on the south 45 degrees 00 minute 00 second east bearing. You might look mathematically correct. An attorney might not realize that's wrong, but you may set a rebar 150 feet from an established rock corner that will have catastrophic effects. So in order to properly retrace a boundary, we have to understand the methods and the precision, not necessarily the accuracy, because the accuracy is where it is on the ground. We're charged to be accurate. We're just concerned though with the methods and the precision of the prior survey or description. So the source of older descriptions can be from many different places and mean many different things. Sometimes, in full disclosure, we won't know this. This is partly because attorneys have notoriously left off references to the source of the description forever. I don't know exactly why, but they will often look at a perfect, or at least in days gone by, it's much better now. It's not uncommon for an attorney to have looked at a survey by John Doe, PLS number 1555, with company name, everything right there, and create a long meets and bounds legal description from it and never cite the source of the surveyor. Not only that, but they may have done a sloppy job. The plat, I literally saw where the plat said a 1.5 inch open top pipe at a fence corner, and the description that the attorney drew merely said to a point, to a point, to a point, to a point, which really convolutes the meaning of the description, because a point is just a point in space. A 1.5 inch open top pipe at a fence corner is a defined monument that we can go find. Anyway, so in looking at where the descriptions come from, sometimes they were made by a good surveyor, sometimes they were made by an amateur surveyor, sometimes they were guessed at. Sometimes it's hard to tell the difference on the face of the document, on the description. Hopefully we have that actual prior survey handy, and it's available, and we can take it, survey by it, and interpret it on our own. But sometimes the description may sound like it was prepared by a surveyor, but you might scratch your head. So it's important to realize that, prior to 1978, except in Fulton, DeKalb, and Chatham counties, I believe, and this varied a little bit with time, the law required licensure as a surveyor only if you were surveying in one of those metropolitan counties with a certain population. So after 1978, they required licensure in any county if you were going to be offering surveying to the public. But before 1978, which is not all that long ago in the context of time and property in Georgia, and I believe it was 1969 in Tennessee, so it's all relatively recent, if you look at the history of the country, recent development to require licensure for land surveyors. So if the description came about in the time when licensure was not required, and the description doesn't cite a particular surveyor, or even if it does, that surveyor may not have been licensed. I'm familiar with land surveyors that, based on what the client wanted, based on the value and the terrain of the land, they may have used stadia for distance, but yet turned angles to the nearest 15 minutes or quarter of a degree. Some in the 1970s even were still using a compass for bearings, and they would slope chain. And if they forgot and that means to measure along the ground. They were not using a gunner's chain, which we'll talk about in a moment. They were probably using a cloth, fiberglass, or measuring tape that was laid upon the ground. Obviously not very precise measurements, but they weren't really doing anything wrong, because even though they were self-professed land surveyors, prior to 1970, there was also no technical standards that guided what surveys had to be in regards to precision and content and so forth. So I want to put in context, though, where a lot of this came from. If you see a really poor description on a piece of property that may be worth hundreds of thousands of dollars today, I'll give you an example of a piece of property that goes back to a transaction around, if I remember correctly, 1962. The deed said 10 acres more or less. It sold for $500, which is $50 an acre. It wasn't very valuable land then because it was very steep, mountainous land. You couldn't farm it, you couldn't build a house on it. It was without a whole lot of trouble. Well, now it's got a long view and it's very valuable. But back in 1962, let's say that property was selling for $500 an acre. And let's say a cheap survey by the guy who used a compass and cloth taped or used stadia, let's say he was going to charge $50 to survey it. Regardless of the dollars, that's 10% of the property value. That's like saying a $100,000 lot, the survey bill would be $10,000. So people didn't do what was even a cheap survey. And I was given the example once of a piece of property in Forsyth County by the property owner at that time, whose father-in-law had owned the land that I was surveying at the time, that was a cotton field. And they had gotten because they had to borrow money at the bank, they had two choices. The local surveyor, who had almost no training, who wrote the distances on the plat and all of his notes and bearings in cursive, hand-drawn, handwritten, distances with 100-foot cloth tape, bearings to the nearest 2 degrees from a small pocket hand compass. And because it was prior to 1978, this was accepted by the bank. But the bank also wanted him to get a quote from an Atlanta surveyor to come up with a transit and a steel tape to survey it and certify it with a seal. And that survey quote, I don't remember the dollars, but it was literally slightly more than the man was giving for the property. So understand, people were not being careless or had any kind of bad intentions. It just didn't make good economic sense. It would be like buying a $20,000 car and deciding you wanted to pay a mechanic $20,000 to check it out before you bought it. simply not going to do it. You're probably not going to pay $2,000 to have a mechanic check out a $20,000 car, which is 10% of the purchase price. So as you look at older descriptions, it's easy to become scornful or seem like this is just a total disrespect to our profession and what we do, and that may be fine and might even be accurate in context of what we're doing, but just understand that people were doing the best they could and making decisions that made the most sense to them. So, like I said, sometimes the previous surveyor is actually no surveyor at all. We just have to understand these things when we're retracing these boundaries. So, compasses used in early surveys. If you have any surveying experience or have been around much, you may think of a compass as that small folding lensatic compass or sight-through compass that weighs a few ounces and will fit in a shirt pocket. They didn't have those much in the older days, and if they did, they were even a lot less accurate than they are today, and people would not have used them to try to survey land. Probably some would have, as per who we were just discussing. When surveyors were actually doing survey work, let's say 100 or more years ago, they likely used a staff compass. It's called a staff compass because if you're taking a sight with it, if you're taking a bearing with it, you need to rest it on a staff, on top of a staff, a long piece of wood 4 or 5 feet long, because they weigh about 3 pounds, give or take, and they're about 15 inches long. This slide includes a copy of a staff compass, which I purchased from an old retired surveyor. It was made somewhere around 1875. So this was brand new tools of the trade to somebody in 1875, nearly 150 years ago. And I've laid a 12-inch engineer scale on the face of it so that you can see how big it is. Part of it is 15 inches someone determined was long enough to be able to sight a good line. You know, the error in your eye and in your hand, it's analogous to you can aim better with a rifle with a longer barrel and the sights are further apart than a short barrel pistol where the sights are very close together. Obviously the rifle is a more accurate and precise weapon than the short barrel pistol. Same thing with the compass, and diligent surveyors were trying to get accurate bearings. Now, these could be read to the degree or sometimes half a degree. Sometimes you could infer or estimate to the nearest quarter of a degree or 15 minutes. But it was generally with, at best, a precision of 1 degree. So whatever you would have recorded, you might be off a degree and never know it. And that's when it's working properly. You'll see in this diagram, there are bubbles, vials, level bubbles in both planes, or both directions, one on either side. So it had to be level front and back and level left to right in order for the needle to freely float. Wow, a lot to go by just to get what we consider now to be a crude bearing. So, you know, here's the vial where you would read the bearing, and then you would sight it through the holes on either end of the vanes, and then here are the pair of the levels. So if you weren't careful, you could get a bearing that was off a lot and not realize it. One thing that better surveyors did was they recorded the bearings in both directions as a check. So if you were taking an observation and determining the bearing from A to B, say it's north 35 degrees east, when you got to B, you would sight back where you came from. And if it wasn't south 35 degrees west, you would try to figure out what you did wrong. And a lot of the measurements in the early surveys were made with a chain. This is a picture of a gunner's chain, which I have acquired, which is really just a chain. Now, one of the links is very long. It's basically just one long piece of real heavy gauge wire or thin steel. And then you can see there are knots, or links, just like links in a chain. These are meant to be 1/100th of a gunner's chain apart, which is, a gunner's chain is 66 feet long. Gunner's chain has 100 links. 66 hundredths of a foot equates to 7.92 inches, which is or just right below 8 inches. 8 inches being 0.667, or 2/3 of a foot. So the link would usually consist of this one long link and then smaller links to facilitate easy movement. The handle would usually have a swivel in it, and that's where you would measure from. And right here at the square face of the handle is where the distance in chains would be measured to. Now we also look at chaining pins and some things along the way, which we'll get to, which could make for more accurate chaining. But this was the gunner's chain that you'll see a lot on the FS exam, a lot of things to do with gunner's chain, links, and area calculations, which we'll get into a little bit more, perhaps more in the next class, but we definitely want to touch on it here. So the gunner's chain came about as part of Edmund Gunner, who was a brilliant mathematician in England 400 or 500 years ago. And he developed a chain which was 4 perches or 4 roods long. Now, brief interjection, these diagrams come from Milton Denny's book, Surveying the Land. Milton is a retired professional surveyor and professor of surveying at Auburn University. He speaks at several continuing education seminars, and before he kicked it back a little bit, he wrote very frequently in publications like POB and the American Surveyor. Milton is a heck of a guy, and he's given me permission to use the diagrams and some of the material, anything that I want from his book in this class. And the book is a couple hundred pages long, and it contains a lot of things that are very interesting to survey history buffs, but I have taken out excerpts that are really relevant to this and condensed it to, I think, a dozen and a half pages. So that's where these diagrams came from. So I want to look for a second at this little diagram here in the lower right. So somewhere estimated to be around the year 14 or 1500, when England began to be interested in property and boundaries, they figured out that they needed a consistent unit of measurement. How do we measure land? You go back that many years, things were not given. So what they came up with is a rood, R-O-O-D, and it was a distance. Keep in mind, there was no English foot of 12 inches. There was nothing. So they came and they said that what they would do is they would take the average of several observations of 16 average men after church with shoes on. Everybody wasn't wearing shoes all the time, but these men with shoes on, 16 of them, lined up, left foot to left foot to left foot. That unit later became known as 16.5 feet because they took the average size of the foot into account and took the shoes off. And that's how they came up with 12 inches as the average foot. But this was even before that. A rood was basically 16 feet with shoes. So they began to use area measurements based on the rood. Now, the rood was also known as a pole or a perch because they wound up cutting a pole that length, and that was used to measure by. That's kind of how they started, was basically a 16.5 foot long pole, and they would use that to measure and count how many poles it was. Well, since that had already been in place for a while, when Edmund Gunner came along, he decided that a good length of pole was 4 roods, which we now know is 66 feet. And understand that roods and poles and chains and acres came before feet in square feet. It's just coincidental that we wound up making it 43,560 square feet in 1 acre. It's actually, I believe, 10 square chains. So that's how they measured acreage back then. So these gunner's chains would be used, and you can measure to the nearest link, which again is a little bit less than 8 inches. That's fairly precise if you're going out into the raw countryside of England 800 years ago or so, or 600 years ago, and trying to measure off land. So 66 feet long, a chain with 100 links, you can measure the nearest 100th of the length. Now, I saw surveys prepared in the last 10 or 20 years which were done with precise equipment and drawn on CAD, but the distances were stated in chains, and it was drawn to 1 inch equals 40 chains or whatever, because it was a large acreage tract. That's just how things were done for a long time. But a little word of caution, if it says 4 chains and 56 links, it's okay for math purposes to try to get ahead of the game and be thinking about it. Realize that 4.56 chains, just coincidental hypothetical distance, is 300.96 feet. But don't go out there and stake out something at 300.96 feet. That's only to the nearest link. That's only to the nearest 10th of a chain, or the nearest 8 inches. And so you could be off 2 or 3. You know, if you state a distance to the nearest 100th, if you say that if the previous surveyor measured a line and said it's 151.45 feet, and you come along and measure it and come up that it's 151.41, you're only off 4 hundredths. You don't think that's too bad? Well, what if he's off 4 links? Now that's 32 inches. That's nearly 3 feet. So don't put too much stock in taking these measurements beyond their significant figures. So because 66-foot chain is kind of long, kind of heavy, kind of expensive, money was tight, most surveyors used a 2-pole chain. It's 2 feet, it was 2 poles long, or 33 feet as we know now. And here is a diagram from Milton Denny's book of 2 colonial surveyors using a 2-pole chain, which actually is a lot shorter in this diagram. It's probably not to scale, and a 5-foot staff. A lot of the distances were intended to be measured with the pole or the chain supported 5 feet off the ground, or like the average height of someone's eye back then. People were generally a little bit shorter than they are now, I believe. Now, talking about compass bearings. No study of early surveying is complete without the topic of magnetic declination. Maybe you've never heard of this before. So a pure magnetic observation uses the magnetic qualities of a steel needle drawn through its polarization as a piece of metal to the magnetic field of the Earth, to the magnetic pole. Well, the magnetic field is centered way up near the North Pole, but not exactly on the North Pole. And this pull differs where you are on the face of the Earth. So magnetic north is pointing towards the magnetic field, not true north. This creates a lot of problems if you're trying to retrace a survey, because if you have a bearing to the nearest degree, or even more precise than that, you have to know what it's referenced to. That's the meridian. And we'll study that more in boundary analysis. But understand that the magnetic field is not centered on the North Pole. It's also not stationary. It moves around with the climate, with the revolving of the Earth. It moves somewhat unpredictably. So magnetic north is rarely the same as true north. It's kind of like a broken clock that says it's 2:05. It's right twice a day, the rest of the day it's wrong. Magnetic compass may be right every once in a while, or once every few dozen years, but most of the time it's off. So surveyors learn to compute and keep track of the difference between their magnetic compass because it's fairly consistent. It changes year after year, usually a degree, sometimes less, sometimes a little bit more. But if your compass bearing that says due north is actually north 7 degrees west, then you can make that adjustment. You would know. So a good surveyor would either use true magnetic and say magnetic north taken 1941. Then you could go back to the USGS, they put out charts, figure out where you are on the earth. This diagram on the left side is a sample of one of these charts. And like on this diagram here, if you're in North Georgia, you're probably about 3 degrees west. So if you look at where we are right here, just say the Atlanta area, North Georgia, you're going to be in the area of about 3 degrees west. The agonic line is where the magnetic north is the same as true north, and over here magnetic north is 5 degrees west of true north. So if you're over here around Easley, South Carolina, for example, and these change, but according to this declination map, if you're around Easley, South Carolina, your true north magnetic compass is actually pointing north 5 degrees west in the realm. So what they would do in modern days here is they make a declination ring, and you can adjust the arrow so that it's actually pointing due north instead of 5 degrees northwest. And so you want to do that so that you have a consistent bearing, because true north is consistent. Magnetic differs. So surveyors would say they would either typically try to offset for their declination so that their bearings are true north, and they would kind of confuse things by saying this is true north magnetic or magnetic derived true north. One term that you'll need to know for future reference is the agonic line, which is where there is no declination. The magnetic north and the true north are actually the same. Doesn't happen very often, like I said. So chaining measurements in early surveyors. So this is one of the things that often you do not know when you look at an old survey or you read an old legal description. Did they measure along the surface of the ground, or did they try to measure along the horizontal? By this time you've had some surveying classes, and you know that measurements are to be stated along the horizontal. They didn't know that in years past. Some surveyors felt like it was proper to measure along the ground surface so that the result could be repeated. So because obstacles, ravines, steep hills and all would be retraced the same way. In other words, if you started at the same oak tree and you went down and the end of your tape wound up in the bottom of a ravine, and then you started measuring up from the other side of the ravine, you're going to measure a longer distance. But if you span across that ravine, half on each side, you're going to be off by several feet. So we got to remember and understand that the shortest distance between 2 points is always a straight line. You've heard this all of your life. Anything less than a true horizontal straight line measurement creates an over measurement. What do we mean by that? Well, let's look at this diagram, these two examples in the northeast, the upper right part of your screen. So here the light dotted line is a little irregular, but it's not too far off. So it's measured 700 feet along the dotted line in one plane, either left and right looking at it map view, or vertically if you want to look at it like in a profile view. And in this case, this amount of variation from the straight line creates an actual measurement of 689.9 feet. I think that's actually 698.9. I'll need to correct that. So it's just off about a foot. But if this is the profile view of a measurement along a surface of the ground like this, or if it's in the horizontal plane and they measure around trees and through a briar patch and they can't tell, they can measure 700 feet along this light dotted line. But in this example, the actual distance from the start point to the end point is only 639 feet. So it's off about 60 feet in 700. So that's something else you have to keep in mind is when they were chaining, if they didn't chain in an exact straight line, if they chained along this dotted line and a perfectly flat land, you still get that much error. Just from being off, not being a straight line from point A to point B. So we know that in the USPLSS states, the requirement from before statehood required that all distances to be measured horizontally by federal law. So keep that in mind. This applies to colonial states where surveying standards didn't come along until around the time I was alive. So older surveys and descriptions that are older than me, we don't know if they were slope chained, measured on the ground, or whatever. Good surveyors, trained surveyors, knew that the horizontal was actually the only repeatable way, because there could be all kinds of errors in slope chaining even along a repeatable alignment. And this example is from Milton's book, Breaking Chain. And that's what they would mean by they would break it down. Instead of being 33 feet or 66 feet, however long their chain was, you would measure a horizontal line to where one chainman was measuring along the ground or at a point on the ground. The other, as high up as he could, would drop a plumb bob to a point on the ground, and then they would measure the chain horizontally. And it would be just like stair steps until they got from a part of an incline or a steep area to another. So, it was always possible to measure precisely. Washington, D.C. was laid out just before the year 1800, and it was laid out with better precision than the city of Atlanta was. And then surveys were being done in the 1960s even. So something else we have to consider are field notes. So truly following the footsteps of the original surveyor would require us to go get their original field notes, but those are not always available. They're rarely available. On a district or land lot, we can find them. We've looked at them already, and you know how hard they can be to interpret and follow. So here's what we just really need to know is that field notes were a source of error that you may need in interpreting an old survey. And there's more about this in the reading, but one thing is illegible numbers, which I've kind of illustrated over here. We'll come back to that. There's transposed numbers. I will tell you that of the 2 traverses that I busted when I was a crew chief 30 plus years ago, when we were taking our observations and writing them in a field book with a pencil, the 2 traverses that I busted where we had to go try to look for the error because the closure precision was not good enough were transposed numbers. Don't know if it's just the way I'm wired. Don't know if it was something I thought I heard, because it was good practice to say your measurement out loud. We would veer into the side of the instrument and manually dial in a vernier. Say the angle was 89 degrees, 12 minutes 56 seconds. We would say to ourselves, vertical 89, 12:56, and then write it down. The fact that we heard it and said it made it more impressionable. That looked kind of silly if there were people around, so you used your inside voice. Some people didn't do this at all, but I transposed distances. In one, I transposed 97 to be 79. Went back and found it, poof, there it was. It's 97 feet. I wrote 79 in the field book. There's my 18 feet of error. Problem solved, go back to the office. The other was something similar. I believe it was 65 and 56. So you can get transposed numbers pretty easily. You can also get erroneous numbers. Let's just say that you look in there and you think it's 78, but it's actually 77. Some of those old verniers, you were measuring off of one side or the other, and you could see that you were almost to 78. So the correct angle was 77 degrees 56 minutes, but you're looking at 78 because you're nearly there. You're far from the 77. According to the vernier, you might not even be able to see 77. You may just see a bunch of minutes, maybe graduated every 10 minutes, and then you see 57. Well, you're just going to record 57 and then the odd minutes instead of 56, or 58 instead of 57, etc. So you could get erroneous numbers pretty easily. You could also get erroneous numbers because of not having if it's a staff compass, if you didn't have it totally level where the needle could freely float, it had to be totally independent just to float. If it was bound or touching on part of it, your bearing could be off 20 degrees. Lots of ways to get erroneous numbers that wind up being interjected onto a plat and or into a legal description. Another one is miscounted chains, or what they would call dropped chains. On the gunner's chains, fancier ones had little tally pins. Every time you measured 100 feet, or one full chain, 66 feet, you just roll that tally over, and just kind of like an umpire counting pitches. And so when you got up there, several people would be part of a survey crew, and not just one or two. And so the head chainman or the note keeper would say, "How many is that?" 7 chains. Then they would count the links. 7 chains, 56 links. That would be what was recorded. What if he miscounted? What if it was actually 6 chains? Now, if he said 37 chains, people would have been like, "No, we hadn't come that far." If he said 2 chains, they might say, "No, I know we've come farther than that." But if you're off 1 chain, sometimes even 2 in a longer distance, it is not readily detectable. Sometimes they would just map it. Something like, some of our legal descriptions had busts in them that we analyzed in interpreting legal descriptions module. Those were there to kind of prove a point. A lot of these old surveys, was it, where was the error? Did it really matter? Was it good enough? Yeah, it was fine. Let's go on. So if you surveyed 160 acres and your survey was out 1 chain, that may have been just how precise your survey was, 66 feet. Or maybe your survey was darn near perfect, but you had miscounted a chain. So you might say that the west side of that land lot's 39 chains long when actually it's 40 because you dropped a chain. So, miscounted chains, that's a common source. Now, one thing that's very avoidable, and it's not as important today with all of the electronic data collection, but it's worthy of mention, is correct numbering. These numbers look like the numbers on your smartphones and on your keyboards. This is how we're supposed to write as surveyors, scientists, engineers. They taught us in elementary school to write numbers like this. This can create a lot of problems when we're writing numbers down that have to be interpreted, analyzed, stored, recorded, used in some way. So this number right here, I saw something similar to that one time. The question was, why did you use the number Q? Does that mean something in scientific notation? What do you mean Q? No, it's a 2. You just kind of got a long stroke. That's because they were trying to draw it like this instead of like this. Or could it even be an 8? I can see some similarities to 8. Here's a loop. There's a loop. This number, or this character I saw a lot, it's often misinterpreted as a 6 because it looks like a 6, but it's actually an 8 made with the figure 8 motion. The correct way to make an 8 is 2 circles on top of each other. The way they taught us in school was to make a figure 8 like that. Well, if you get the top part overlapping each other a little bit, it can look like a 6. A 4 drawn correctly has a point on top. It is the only character that has a point on top. A 9 is a nice smooth arc. They taught us in school to make a 9 like this, which kind of has a point on top, as does the 7. The 4 has 2 points. The correct 4 has only 1. So is this a 4 or is it a 9? It's a great question. You see this in an old field book. That's a measurement. Is that a 5? Is that a 6? Is that an S? Is it a lowercase b? This one is most interesting. I saw this, and it was basically where the person tried to do that and make a 4. There wasn't a whole lot of tail up here, and they didn't have a whole lot of tail right here, so it just looks like a fancy 7. But it was a 4. Took some trial and error to find out the source of that error. So That's where a lot of error can come from when you're retracing a prior survey. Yes, it's not uncommon to look at that, especially if the reproduction is blurry, and say, is that a 3 or an 8? Part of it's missing. Is that a 5 or a 6? Is there a back in the back of it, or is that straight or is it curved? Finally, before we get out of historical surveys, I consider electronic distance meters, total stations, and GPS to be a current or a modern surveying technique. The transit or the chain and compass evolved to the transit and chain. So this is a 1 minute Gurley transit that I own. That's a picture that I took for this lecture. It's very elaborate, very heavy, comes in a big box. It made vertical and horizontal angles, had to be leveled, and it even had a little compass right here on top of it where you could get a compass reading. The only problem with that is it's surrounded by steel. Lots of things that can distract the needle. That was another problem with compasses, that Western surveyors often had draws on their compass bearings in their field notes because they had a pistol that had a little magnetism in it, and they held their compass too close to it. Might pull it off 2 or 3 degrees. 2 or 3 degrees is a lot in a section line. And the chain with links, even the 2-pole chain, was eventually replaced with the steel tape. And this is a 200-foot steel tape on a reel, which I acquired from a surveyor in 2012. He had a lot of them from where he had used them as recently as the 1990s with a theodolite. Now this is a transit. They became more precise and a little bit smaller, and to distinguish them from the cruder, less precise transit, they were called theodolites. One thing to point out is that even though this is a steel tape here in the upper right corner on a reel that you'd reel it in by, older surveyors still called it chaining, or this is my 200-foot chain, even though it was a steel tape. So, in summary, thanks again to Milton Denny for the illustrations in his book. When we're doing a retracement, there's like 3 points I want to make. Always be cognizant of the source of the description. If it is not stated, then nothing can be assumed. Don't assume that it's from a surveyor. Don't assume that 300 yards means 900.00 feet. It could be 300 paces. A lot of descriptions made by non-surveyors, the distances were paced. It might have been a short-legged person, it might have been a tall person, long-legged person. But it's also going to be along the surface of the ground. So it's like slope chain. If it looks like a good survey, but you don't know the source, still take it, trust but verify. We'll get into this more in boundary resolution, but usually you'll find if the previous description is based on an actual survey, or if you have an actual old survey. And let's say that because of all these various sources of errors and slope chaining and tape correction, that let's say that you come up 100-foot line winds up being 99.2 feet long, and it's short line, shouldn't have a whole lot of error. And you find a 300-foot line that measures 297.4. Well, that becomes a consistent factor that you can use to not go sit. If the next pin's supposed to be 100 feet, you probably don't want to look at 100.00 or set a pin back at 100.00. You probably want to go with that 99.2 or whatever that first distance was to be in context. We're scaling basically at that point. And there, if the source is known and it's a prior survey, understand the precision and the efforts of the prior survey. Did they use an actual chain, or did they use a steel tape? Did they pace? Did they measure along the ground? Where did the bearings come from? Was it from a compass? Did they make the mistake of saying 12 degrees 30 seconds when they meant to say 12.5 degrees? Sometimes you can tell a lot by interpreting the description. If all of the bearings are either even degrees or 30 minutes, they've broken the law of significant figures and imply that it's not 29 and not 31, it's 30 minutes, but really it's a half a degree. So be cognizant of the prior measurements precision and the significant digits. Don't invent something that's not in the original survey and put it in there. Finally, mention of the state board rule. We have horizontal measurement precision requirements in this state board rule, which provides for positional tolerances, closure precisions, all for good, accurate surveys. Some people used to think that you could not take a tape out of the back of the truck and a pin finder and a compass out of your shirt pocket and try to follow the previous survey to find some starting points. So this rule was added several years ago. It says where original surveys in rural areas were made with a compass, retracement may be made by compass in order to follow the footsteps of the original surveyor. Duh. However, such retracement also must be reduced to a non-magnetic traverse so that the area of closure, as specified in the rule above, is obtained. So some people would think that you couldn't do it. Other people thought, well, the previous description was done with a compass and a cloth tape, so that's how I'm going to retrace it. And they put out a plat to the nearest degree and the nearest foot because that's how they retraced it. No, it is a tool. This following in the footsteps is a tool to recover evidence from which to make boundary decisions. It's not a technique on how to resurvey. So, I hope you learned something about the historical context of old surveys, descriptions, and surveying methods, and how they impact retracement surveying. Thank you.